this particular demo, as I told, we were going to look at event-driven service. This is the typical thing that I have created out of curiosity for understanding the event-driven architecture using Kafka and could be any databases, sort of, let's say MongoDB. This is how the service handles high-volume API requests by leveraging Kafka for messaging queuing and the event streaming for the post request. So the main goal is to do the optimization on the post API in backend using Kafka. So overall, if you look at the high-level architecture is kind of this, where there are the like, let's say 100 concurrent virtual users who are going to send a concurrent request for a certain period of time to a particular like a particular system. Now for this matter here, for this event-driven service, I have written two endpoints. One endpoint is create post without Kafka, which is the native API, which calls out the particular user's request on their behalf and creates a post using the direct writes to the databases. And in this case, we are using MongoDB. I'm using MongoDB as the primary database, and writes like direct writes. And we have seen some certain number of requests per second over here. And there are another endpoint who leverages with the name of create post with Kafka, sorry, which produces to a Kafka streaming with almost double of this particular request, less than a double, but almost nearly a double request per second to a Kafka queue, and which then consumes streams into the MongoDB database with the fault-tolerant and the scalable system. So one system, using one kind of REST API method, we are able to achieve, let's say, 8k requests per second, but using a Kafka and event streaming, we are able to achieve almost double of the request per second RPS. Yeah. We have discussed already the architecture, and right now we are going to see the how things works in action. Right now, in the project structure, I would like to go from first, that is the Docker Compose. So in the Docker Compose, right now I am using Zookeeper. Then we have a native Kafka service as a single node standalone. MongoDB is there for the database, and Mongo Express for the just the MongoDB database UI easy access. And there are a couple of volumes that are being created. Now from the project structure, if you look at, there is one makefile which basically runs the container and runs some tests that I have written for the API testing, performance testing. Now there is one directory that is called microservice. This is a name which has a typical very simple implementation of this particular thing. We have a main.go file. In this main.go file, the database client is being initialized over here. Then server configuration is being initialized. Along with that, the Kafka writer, that is a Kafka producer layer, that's been initialized using Golang, and the MongoDB instances has been given. Now I am just creating one new server instance along with this server configuration that I have given, and post that what we have here is basically server.start. Now if we look at specifically for, let's say, what is written in the server.new server, the codes has been written, and it's a Go native net/HTTP standard HTTP library and HTTP server based on Mark. These are the two basic endpoints. First endpoint is create post without Kafka, and second endpoint is create post with Kafka. So one is basically without Kafka, we will check how my API is performing, and with along with the Kafka how it is performing. There is a start layer, and in the start layer the couple of custom microservice middleware layers has been written over here. One is for log middleware, just to log the request response cycle and the time it consumed to process it, and add custom context which has the Kafka writer and the Mongo client inside the request HTTP request context. Okay, we are passing it to. Now let's see the action. We have to basically start couple of things, and there is one consumer layer always. If you look at the handler layers, it is pretty straightforward. In case of I have defined a basic post structure in Golang along with the JSON IP mapping. The create post handler without Kafka, it's pretty straightforward, just reading out the body, adding some additional parameter and saving into the database, and whatever we are saved, we are just logging the error conditions also and returning back as an output. And we are also saving the method. This utility method has been written over here. Apart from that, create post handler Kafka, it has the similar sort of thing, but io.readwell karke we are basically reading the body into post bytes. Once it is there, I am preparing a Kafka message using this particular library, and in the Kafka, from the get Kafka from writer context, that Kafka writer instance is being procured from the request context. Over here you can see passing the background context or the request context. From there I am just taking it to, and the API response cycle is also present over here, right? And this is all it is. It's very straightforward, I believe. And if you see the consumer layer in the post consumer, this is also a small consumer service in Kafka Golang, where there is one simple main method. It has the post structure, it has the Kafka reader configuration, Mongo client configuration, and consume messages as a go routine. So this runs in a separate go routine just to not block the main thread. The batch size is 100, so each and every time the Kafka message has the 100 message batch, or maybe batch interval is 5 seconds, every time it will run as a go ticker. It's very straightforward and simple implementation, but very focused implementation. If you see case.ticker c, jahan pe we are checking the read poster if there is a like not an empty post, and if it is like every 5 seconds take, I am just saving it to a like saving the bulk info to my database. If not, printing the batch interval reach out of no post to process, and then by default it will read the message from using context, do the processing, do the massaging of the data, adding the additional fields which is required, appending the post, and also at the end, if the message hits, then it starts writing out the data, right? Like that format it is written. Now let's start one services one by one. Now let's start with the first consumer, like Docker consume. The API method is that consume app. Okay, so just I will be typing make compose app. If I type that, now in here you can see my containers are getting booted up. Once containers are ready right now, Mongo Express is also ready. If I go to browser and hit a refresh, so this database has been also been created, post with Kafka and post without Kafka. So all the inputs which are coming from post without Kafka will be saved in this DB. Otherwise it will save post with Kafka database. Now we have to start the consumers also. Let's start the consumer. So consumer के लिए in the make file, if you see, this is the particular consumer build method. I just have to write make run, and then it will start auto running the particular. Now here if you see, whatever present in my Kafka already exists in my Kafka topic now, it getting passed out, and this it starts executing that. Okay, and let's start the microservice also. In the microservice, this is your microservice. Here you have to start some couple of services also. Now let's start the couple of microservices. Like here it's a hot runtime that I am using, and there are some tests also. So I am using k6 load balancer test, Grafana k6 test. So right now in this particular block I have to just edit it. One, we have to first test out without Kafka. Right now how I have got it, if you see the server.go file, I have written the endpoint name create post without Kafka. So create post without Kafka. This endpoint we have to hit just to check how my API is performing without any Kafka or event queue. How my API is doing the load testing, and what is the output we are seeing. How many requests we are able to process, RPS, request per second. So right now this particular, if I go here now, goes to with Kafka, I believe there are some databases will have been created. Data is also, oh my god. So within some simple 10 to 20 seconds, this many documents has got created. I will delete it because I don't need it. Almost it's a 500 MBs of data. It's not needed. We will see everything in action right now. Now first we are testing without Kafka. Okay, without Kafka endpoint. Let's try. If I come here and say, for example, before I go there, I will just want to show the request.endpoint. So this is the particular request.http. If I hit Kafka without post, now if I come Kafka without post, there are nothing in present in post, right? These two documents are there. I will also delete them just for simplicity. So we don't have anything right now. So it's a zero post in Kafka without post. Now if I execute this particular curl request, now post has been created. It is saying. Now if I refresh over here, now total document size is one. So one post is right now it is exist, and the ID is that 4769. Here also 4769. So this is particularly working. Now instead of creating one entry, I will be creating a API trace testing using K6. Let's run that and let's see everything in action. Now for the test, now I have re-executed the server right now. So right now the server is running, and if I just execute the Kafka without with Kafka, so there are train entries. I will just delete it, and let's run the API test. Okay, without Kafka first we will try without Kafka, then we will be moving to create post Kafka. So let's run it. Let's run the test. Now if we look at the API test, we are going to run for the create post without Kafka. Make run test, enter. It has started executing the test, as you can see in my screen. And the test will almost take 2.5 minutes as an estimated time, up to 100 virtual users concurrently for 20 seconds. Okay, for 2 minutes. Sorry, for 2 minutes, 100 users will be using this. Over. Now let's see the things in action. The test have two kind of tests. Status is 200 and response time is greater than 300 milliseconds. As we went over on the duration, it is total time taking. Change plus burst time plus waiting time, everything that is milliseconds. We are already on the good number without any Kafka or anything. System is able to process 6 lakhs. Okay, 6 lakhs of records. 670K of records. Pretty good within 300. Within 2 minutes basically. So within 2 minutes, almost 780, 800K. That is 8 lakh of requests or posts is getting created within 2 minutes. There are 80 users right now. It's going good. It's starting, but it is really good. Now if I look at my MongoDB now. Data is also keep getting ingested. If I go to post without Kafka, see the post avail. So total 10 lakhs plus of entries are there and test has run successfully. Now what was this test result? If you see here in the test results, what we are seeing over here is okay, response time is less than 300 milliseconds. So almost 62 requests are there out of this much who are not even close. But P95, if you look at the P95, the waiting time for the request is 17 milliseconds. So which is pretty good, I would say. And if you look at this number, so almost there are total 105,9953. This many requests. This is matching, right? So no request has been failed also. So this much request has been called using this number. I will save this particular result over here. So almost this much entry without Kafka, 8,832 requests per second we are processing without any event queue, without the Kafka. Now it is the time to look at with Kafka endpoint. I will just switch back to with Kafka database, view the post. There are no posts over here, nothing. And let's see things in action, and I will run the test again and we will compare slowly, right? Now if I run again, run the test. So as you can see, it has started working for the with Kafka, and if I see my API logs also, there are so much of request is coming to create post with Kafka, okay, with Kafka, sorry, and this is the timestamp that has been elapsed. And if I look at my Docker logs also, it's pretty fine. And if I look at this particular my consumer layer, that's the Kafka reader, there are so many posts is getting saved here and there. So things are systems is running fine over here. Let's wait till the test ran. Created. 1.1 million requests has been created. So on and so forth. It is keep going. Test is still there, but so many requests we are processed. So requestly it completely from the naked eye now. So we have already surpassed this number. So total within this 2.5 minutes, we are able to process 10 lakhs, 1 million requests, only 1.05 million requests within 2.5 minutes. But right now we have closely surpassed this, and this number is keep getting increased. So 1.6 million requests is being processed. My test has ran, and if you look at the success result also, success is 200, response time is less than 300. Now P95 of my request is 13. If you remember that time it was 16.5 millisecond, but using this the 3 millisecond gap is there. So the P95, that 95% of the request has been covered within 13 millisecond or 14 millisecond for that matter. And this much request has been created, has been processed, I would say, with Kafka. So I just going to write over here. It is basically with Kafka, and the request response cycle is this much. So if I look at my database also, 1063 7191 7169. I guess there are some requests has been stuck over here. If I run that and if I refresh, 7170. Now if I close this, so no request has been killed, but all the requests has been there. 163797. Okay, so the count is also matching the same. So within this 2.5 minutes, it has generated almost 350 MBs of data, and my request response cycle for my with Kafka has increased significantly. Right now, I am able to process 13,000 requests per second. So if I do maths over here, 13,000 requests plus 8843, 1 minus this divided by 8843. So almost it is
40%, 45%, 46% of improvement we are able to map using improved, the faster speed. Okay, so this is the beauty of this particular setup, and I will basically take a screenshot of this just for the reference for later point of time as well. So it is the case testing that we call, and I will save over here test reports, and just save it reports without Kafka. This is with Kafka. So if you look at without Kafka, we are able to process 59 requests per second. Total request it was 1791, but with Kafka we are able to process this much records and this much request per second. The RPS is pretty high, 13,000 requests per second without any data loss or anything, and I am able to capture all the data in my MongoDB database. That's all. I hope you have loved it. That's the magic of using Kafka as an event-driven service for your high throughput system, and it's a very easy implementation. If you over here, the code base will be available on GitHub. You can check out the code and do your experiments. Feel free to do your experiment and the modifications that you want to do for educational purpose. And that's all from my side. Signing off.
Okay,
Thank you.
we are almost completed everything. By let's say if you want to connect with me, this is my portfolio, sonishnath.netlify.app. Here you can find me. You can go to this link tree section. You can connect me over LinkedIn or maybe GitHub repository. This is the GitHub repository link which I will be attaching to the video descriptions as well. From there you can find it. And if you want to connect with me on LinkedIn, then you can basically use this link tree from the this thing, and you can search on my name. You can find me. This is my LinkedIn profile. I would be happy to connect and discuss on case session together. Yeah, that's all from my end. I hope you have enjoyed. Bye.